So in this lesson, I'll be continuing building on knowledge and finding the equation of a cubic function. But in this instance, the fundamental takeaway will be calculating the cubic function using two turning points, which will be interesting and tricky because we'll be generating two simultaneous equations and really solving them. So I'll be showing you really quick and efficient ways of doing it and how to always spot which method to use when in the exam. So by the end of the lesson, you should be able to calculate the equation of cubic function with two turning points. So let's get right on to it. So suppose you're given this exam type question where you're told that the function f of x is equals to negative 2x cubed plus ax squared plus bx plus c. Sketch below. So we're given the sketch and the turning points of the graph are at t and at s. So now we're given two turning points, t, which is 2 raised to negative 9, and s, which is 5 raised to 18. So how do we go about this? So since we're given two turning points, it will be simple and straightforward. We'll be really using the method of finding the turning point, which is finding the first derivative and equating to 0. So what we're going to do, we're going to split this into two parts, right? Two separate parts. We're going to find the first derivative of f at x, equate it to 0, and we're going to do the same thing. Yeah, find the first derivative of f and equate it to 0. But in this instance, we'll be using 5, and on the left hand side, we'll be using x is 2. So remember, when you're finding the first derivative of a function or cubic function, you're finding the turning point. So let's find the first derivative of f, which will be negative 2, drop the exponent of 3, x to the power of 2, plus drop the 2, ax, subtract 1 from the exponent, will be 1, and then we'll be left with b because there's an invisible 1 there. Drop the 1, subtract 1 from 1 to be 0, a number to the power of 0 is any power raised to the power of 0 will be 1. So you're left with negative 6 x squared plus 2ax plus b equals to 0. Now remember, ideally, if we're solving for the turning point, we would solve for x to find the x coordinate for the turning point, but we're already given the x coordinate of the turning point. So what we need to do here is to substitute the x coordinate of the turning point. And that's really the key theme here. Also, we're repeating the same step on the left hand side as well. So what we're going to get here, the negative 6 times 4, you're going to get negative 24 plus 4a plus b will be equals to 0. So this will be our equation 1. You can safely label this equation 1. And we're going to repeat the same step on the right hand side. We already know what the derivative of f of x is, but we can just take it from here. To be efficient and save time, we have negative 6x squared plus 2ax plus b is equals to 0. So we just substitute now 5. We have negative 6, 5 squared plus 2a times 5 plus b is equals to 0. So minus 6 times 25 should give us negative 150 plus 10, 2 times 5 is 10a plus b, or equals to 0. This will save you the our equation 2. So now we almost at our answer. So now we just quickly and smartly use simultaneous equations. So we have to make one equation 3. So we take one of the simplest equations of the two. So let's just make room. Yeah? The equation that looks less intimidating Either way, we can use equation 1 where we make b subject. If we make b subject, we take negative 24 and 4a to the right hand side, which will be positive 24 minus 4a, and this will be our equation 3. And what do? We substitute equation 3 into the unused equation. Equation 2 means where there's b, we're going to substitute 24 minus a. We can go ahead and do that. We're going to have negative 150 plus 10a. Then we're going to substitute 24 minus 4a is equal to 0. So now I use a quick and easy technique to always get really these correct, is to always highlight the like terms so as to not get confused, and I always highlight them with the sign in front of them, which makes it easy for me. So I have negative 150 plus 24, and that should give us negative 126. Then we have 10 minus 4a, and that should give us positive 6a equals to 0. So we make 6a subject, which will be equals to 126. Divide both sides by 6, and 126 divided by 6 should give us 21. So we found what a is. How do we find b? We find b by substituting this value into equation 3. Why equation 3? Because equation 3 already has b as subject. So in equation 3 we have b is equals to 24 minus 4a. So b is equals to 24 minus 4 times our a value is 21. So if you punch that into the calculator or do some quick mental maths, you will see that we'll get an answer of negative 60. So far so good. We found what a is, 21, found what b is, negative 60. Then how do we find c? This is the most important, because now we've done all the heavy lifting, we've done most of the hard work. Then how do we tie everything up? So I'll show you that. So let's just substitute all our values into our equation there. So we're going to go ahead and say f of x is equals to negative 2x cubed, and our a value is 21 plus 21 x squared, and our b value is negative 60 x plus c. So c is the unknown. How do we get this unknown of c? So we have f of x, which is y, we have our x's that are unknown. So we can just simply substitute a point on the graph. For example, we can just take t, which is 2 is to negative 9, which will be our x and our y. If we substitute x and our y into this equation, we'll have c as unknown. Then we can just simply calculate what c will be. So where there's y, we can substitute negative 9, will be negative 2. Where there's x, substitute 2, 21, 2 squared, minus 62 plus c. So if we calculate everything over there and take it over to the left hand side, should find that c is equals to 43. And in that way we would have calculated what our a is, which is 21, what our b is, which is negative 60, and what our c is, which is 43, and it coincides with a being 21, c being negative 60, b being negative 60, and c being 43. And the summary or the quick takeaway here is to really master the concept of when you're given a turning point, you know the first derivative of that function equals to 0. We substitute the turning point, the x value of the turning point, substitute the x value to the turning point, and that will give us our equation 1, and we repeat the same step when you're given the other turning point. in this case, let's call this x1, and then we substituted x2, meaning that the x value of the second turning point, and it gave us really equation 2. This really is the core principle. Yeah. And then you saw how we found C. We just found C by just substituting any random point on the graph. And the point needs to be on the graph. And so if you found value into this video, please hit the like button and be sure to look at the next video, which is the 4th video on finding the cubic function. And there I'll be showing you how to find the cubic function when you're given the tangent.